Incomplete dominance. For the first part of this, we were talking about complete dominance, where you're either dominant or you're recessive, and if you're heterozygous, you show the dominant trait. Well, that's not true in everything. Sometimes we have incomplete dominance, which I kind of like to think about as mixing paint. And so, especially with our example that we're using in this one, if we have snapdragons show incomplete dominance, red flowers have the genotype big R, big R, white flowers have the genotype big W, big W, and then we also get pink flowers when we have the red gene and the white gene. And so we're mixing the two together. And so here we're asking us to cross a red with a white. And so the reds, again, are always going to be big R in incomplete dominance, and the whites will always be big W, big W. And so our Punnett square, we'd have our R's and our W's, and all of these offspring would be RW. So our genotype ratio would be 1 to 0 of pink. Oops, sorry, I got ahead of myself, of RW. And our phenotype would be 1 to 0 of our color, which is pink. And so other than that, you pretty much work it the same. In here, if we cross two flowers from the square above, so that is our RW crossed with our RW, fill out our Punnett square there. And the way we actually figure out if a plant is complete dominance or incomplete dominance is we cross the middle of the road one, the pink one, and we see we get kind of a cool mix here. And so I would do this, our genotype ratio of RR to RW to WW. Our RR, we have 1 out of 4. Our RW, we have 2 out of 4. And our WW, we have 1 out of 4 again, so we get a 1 to 2 to 1 ratio. And of our colors, the red, pink, and white, we again get a 1 to 2 to 1 ratio. And so you're going to go ahead and work these. Pretty simple and straightforward. Come on up and check with me once you're done and see if you got it right.